Alright, okay. Welcome to this lesson of Chikamanga. Now, in today's lesson, we're going to look at a simple machine. So, we understand the simple machine by definition is a device that uses SF4 to overcome huge load. So, the diagram that we're seeing a pulley system. This is just an example of a simple machine. So, the question is saying figure B3.1 below shows a pulley system. So, this is a pulley system that we're able to see here. Okay, so the pulley system has what we call the effort, which is also one of the forces that we have on the pulley system. So this effort is also a force is measured in newtons, so we need to understand that. There is also another rod here, which is our 120 newtons. So we are able to see that for sure we have this one, which is a force, and also this one is a force. They are both forces and they are both have the same SI units. So our first question is saying state the velocity ratio of the pulley shown in figure B3.1. State the velocity ratio. So if you have been given a pulley system like this one, the easy way of finding the velocity ratio, you just need to count the number of loops that are there. So we have the first one, this one, and also we have the second one, that one. So the velocity ratio in this case, it is 2. So 2, it is our velocity ratio in this case. So we need to understand that. Okay. We come to B. We're saying if the efficiency of the pulley system is 75%, what is the mechanical advantage? So we have been given the efficiency, which is we have been told to say 75%, that is the efficiency. So what we are just trying to look at, we want to look at what is the mechanical advantage. So when calculating this one, we understand that the efficiency is equals to we have mechanical advantage, then down there we have the velocity ratio. So this is our formula. So mechanical advantage over velocity ratio times 100. So this is a formula that we use in calculating the efficiency. Okay, so times 100%. Now what you need to note is that the efficiency have been given, which is 75. So 75, that is our efficiency. So what we just need to do in this case, we just need to replace where there is the efficiency, we'll put 75. Where there is mechanical advantage, this is what we need to calculate. And also where there is velocity ratio, we have a 2 that we have already found. Then we do the arithmetics and we'll be able to find the mechanical advantage in this case. So that is very, very important that we should be able to note. Okay, so now when coming to our calculations in this case, so what we're going to do, we're going to have to do what I've just mentioned. So let's look at our calculations. We'll say efficiency will be equals to we have mechanical advantage, then this one is divided by the velocity ratio. Okay, so this is going to be our formula. Okay, so we're going to say the velocity, the efficiency we've been given, which is 75%. So we need to understand that. So we've been given 75%. Okay, that is our efficiency. Then we'll say equals to the mechanical advantage. It is the one that we're looking for, divided by we have velocity ratio, which is also the 2. Then we need to times 100%. Okay, that is very, very important to understand. So we do not need to forget the times 100%, because the efficiency is calculated in percentage. So that is very, very important to understand. Okay, so what we have now, it is an equation that will make us be able to find the mechanical advantage. Okay, so in this case, when you do your multiplication, you are going to realize to say what you are going to have. You have mechanical advantage. You have mechanical advantage, of which this is what we are looking for. The value for the mechanical advantage will be equals to 75. Then we have times 2 over 100. Okay, so we have that one. Mechanical advantage is equal to 75 times 2 divided by 100. So 75 times 2, we're going to have 150. Okay, 75 times 2, we're going to have 150. So our 150 there, then we say 150 divided by 100. Okay, 150 divided by 100. Okay, so our answer in this case, it is going to be 1.5. Okay, so this is going to be our answer. So we need to understand to say, we just need to draw it nicely. The formula will lead us to finding the actual answer that we need at the end of the day. So the answer that we needed, it is 1.5, which is going to be our velocity ratio, like that. So that is very, very important. So what we are seeing, that the most important thing in this case, we need to master the formula so that it can be able to assist us when it comes to the calculation, because without the formula it is going to be very difficult. Okay, let's come to our C part. So the C part, we are saying if the load is 120 Newton, what is the size of the effort? So the load we have already been given to say it's 120 from the diagram. What is the size of the effort? So what we need to understand, again, the formula here plays a major role. So the formula for mechanical advantage is equals to we have load over effort. Load over effort. So this is the formula that we must use whenever we're calculating the mechanical advantage. So it's the one that we're going to use to find the effort, because the mechanical advantage we've already calculated, which is 1.5. The load we've been given, which is 120. So we'll say 1.5 is equals to the load, which is 120, then divided by the effort. Okay, we're just going to represent with E so that it becomes simple. So in this case, when you do your arithmetics, you're going to realize to say you have your effort is equals to, we have 120 divided by 1.5. Okay, 120 divided by 1.5, and our answer in this case, we're going to have effort is equals to 80. Okay, this effort is equals to 80 newtons. So because remember, when I was saying, when I was starting, I said this one also, it is in a force, so that's why we have to put the 80 newtons there to indicate that it is also a force. So our answer is going to be 80 newtons.